the one-dimensional kinematics topic. In section 2.5, I'll be talking about the differences between speed and velocity, the difference in how you calculate speed and calculate velocity. Now, we're going to have to start by calculating distance and displacement. But since you've already done that, I'll try to do that fairly quickly, because you already know the difference between how to calculate distance and how to calculate displacement. Now, the most basic thing is to look at the difference in the equations. All right, speed is defined as the distance divided by the time, while velocity is defined as the displacement divided by the time. All right, speed is the scalar, and you use the scalar distance to calculate the speed. Velocity is a vector, and you use the vector displacement to calculate the velocity. Just for fun, note that speed and scalar both start with the letter S, and velocity and vector both start with the letter B. That's just a little fun fact to help you remember that speed is the scalar and velocity is the vector. Because speed is a scalar, we only care about the magnitudes. We don't care about the directions. But by calculating distance, we're already incorporating that caring about only the magnitude into the calculation of the speed. Because velocity is a vector, we care about the magnitude and we care about the direction. So incorporated into the calculation of velocity is the displacement, which is also a vector, which already incorporates the importance of the direction in the displacement and subsequently in the velocity. Now, just placed very simply, if I were to state a speed, for example, if I happen to be going in one direction, let's say we were going that way, all right, my speed could be 3 meters per second. All right, so my speed, and by the way, speed and velocity also use the same symbol, v. So my speed would be 3 meters per second. All right, v is 3.0 meters per second. But if I were to state what my velocity was, right, in that direction, I would have to say, it could still be 3 meters per second, but I would have to say the direction that I'm going. I could say to the right. All right, so my velocity in that case would be 3 meters per second to the right. 3 meters per second to the right. Other directions could be east, could be north. If you want to go in a negative direction, it could be to the left, it could be south, it could be down. All right? This is a scalar. It only has a magnitude, a number with a unit. The vector has both a magnitude and a direction. So speed is the scalar, velocity is the vector. Now, we're going to do some problems. We're going to have to calculate the distance first to calculate the speed. Then we calculate the displacement to calculate the velocity. We're going to do some problems where we calculate both the speed and the velocity for the particular problem. All right, and here we go. All right, we've got a gentleman. All right, we'll call him Mr. Pierre. All right, and Mr. Pierre, all right, is planning to go, all right, 10 meters east. We're not going to draw it to scale this time. We're just going to do rough little sketches, okay? So 10 meters east, 10 meters east, and then he's going to go 50 meters west. Again, not to scale, but 50 meters west should be longer than 10 meters east. All right, notice again, tip to tail to add these two vectors. There's our 50 meters west. So he starts here and he ends there. All right, that means our displacement is from here to here. All right? Now, the distance that Mr. Pierre covered, all right, the distance that he covered would be d1 plus d2. I think we're going to move that over just a little bit more. Let's put it over here. The distance that he covered, all right, would be d1 plus d2. All right, the distance is 10 meters plus 50 meters. The distance that he covered is 60 meters. All right, since we know the distance, we can calculate his speed. And it took him 8 seconds to do this. All right, the time that it took was 8 seconds. All right, this was given, and the time was given. The question is, calculate his speed and then calculate his velocity. In order to calculate his speed, we first calculate his distance, all right, and now we calculate his speed. All right, so his speed is going to be his distance divided by the time that it took. Speed is going to be distance over time. The distance he covered was 60 meters. So we've got 60 meters divided by the time it took, 8 seconds. So what was Mr. Pierre's speed? All right, 60 divided by 8, okay, 7.5. All right, so I'll put here V for speed. His speed is 7.5. The unit is meters per second. Meters per second. All right, the distance he covered was 60 meters. His speed was 7.5 meters per second. All right, that's his average speed. All right, now let's do his velocity. And in order to calculate his velocity, we first have to calculate his displacement. So let's get the displacement. All right, remember that displacement is a vector, so the directions matter. All right, now his displacement is right here. Okay, displacement equals, all right, d1 plus d2, but, all right, d1 is 10 meters east, so we're going to put positive 10 meters. d2 is 50 meters west, so we're going to put plus negative 50 meters. All right, you have to subtract when it's west or south or down. All right, so we've got 10 minus 50. All right, so his displacement, we'll put D for displacement, is negative 40 meters. His displacement is negative 40 meters, or 40 meters west, or 40 meters west. Okay, don't put negative 40 meters west. Negative and west cancel, and that's wrong. Okay, it's not 40 meters. Negative and west are going to cancel. You put one or the other. Okay? Now, his velocity. Mr. Pierre's velocity is the displacement divided by the time. His displacement was negative 40 meters. The amount of time that took was 8 seconds. So his velocity, and again, the symbol V is for both speed and velocity, so you have to be very careful not to get them mixed up. All right, so his velocity, all right, 40 divided by 8, negative 40 divided by 8 is going to be negative 5 meters per second. or 5 meters per second west. All right? So the magnitudes of the speed and the velocity are not the same, because the distance was 60 meters, the displacement was negative 40 meters. Right? So the speed and the velocity are coming out with different magnitudes when you go in opposite directions. Okay, let's try another one. All right. All right, we've got a horse. All right, and the horse gallops 30 meters north, and then he turns around. He forgot that there was some really nice grass he wanted to chew on. All right, and he galloped 30 meters south. All right, so the horse gallops 30 meters north. We'll start him here. All right, start. He goes 30 meters north. And then he gallops 30 meters south. And he ends in the same spot where he started. All right, I'm not going to put them right on top of each other. I do want you to be able to see them. Tip to tail. So I'm adding the vectors correctly. All right, so now the distance. All right, we want to know his speed, the horse's speed, and we want to know the horse's velocity. It took the horse 10 seconds to do this. There's a fast horse. All right, so the time, it took the horse 10 seconds to do this. Okay, we'll make, that's all two significant figures. All right, so maybe we can fit everything in this space here. All right, the distance that the horse covered was d1 plus d2. Right, we don't care about direction, so it's just 30 meters plus 30 meters. All right, again, it's a coincidence. The distance that the horse covered was 60 meters. So the speed is going to be the distance divided by the time. The speed is 60 meters divided by 10 seconds. So the speed is 6 meters per second. 60 divided by 10 is 6. The unit is meters per. When you see division sign, you say per, right? Meters per second. Okay? Now, what about the displacement, all right? The horse's velocity, okay, and the displacement. So we get the displacement first. The horse's displacement. Again, d1 plus d2, but south is negative. So what we've got here is north is going to be positive 30 meters plus south is negative 30 meters. So what you've really got is 30 minus 30. Your displacement is 0. Your displacement is 0. Okay? Your distance here is 60. But your displacement is 0. All right? So now, when you calculate the velocity, which is displacement divided by time, all right, you find that the displacement is 0. The time hardly matters at this point, all right, because your velocity is 0 meters per second. Okay? Very, very, very different, the speed and the velocity. Very, very different, the speed and the velocity. Okay? Now, one last problem. All right? Okay, we've got somebody, we'll call this person Fred, okay? Fred is going to go 50 meters south. All right, so from here, Fred goes 50 meters south, and then he goes 20 meters east. 20 meters east. We want to know, it takes him 20 seconds to do this. All right? The time it takes him is 20 seconds. Okay? Now, his displacement is start, right? Here's where he started. Here's where he ended. So his displacement is start to end. That should be straight. All right? If we want to know his speed, we first have to calculate the distance that he covered. All right, so his distance is d1 plus d2. That would be 50 meters plus 20 meters. The distance that he covered was 70 meters. All right, so his speed is going to be his distance divided by the time. The distance was 70 meters. The time was 20 seconds. All right, so 70 divided by 20. All right, how fast was this guy going? All right, 3.5 meters per second. All right, his speed was 3.5 meters per second. Now, what about his velocity? We have to calculate his displacement first. The displacement would be d1 plus d2. Nope, wrong, mistake. It's a triangle. The displacement is going to use Pythagorean theorem. All right, here's the resultant or the displacement. All right, we've got A, we've got B. We're going to calculate the displacement right there. It's not d1 plus d2. You got to use Pythagorean theorem. Okay, so r squared, this is for displacement. All right, r squared is going to be a squared plus b squared. All right, a will do 50 meters squared. B is 20 meters squared. All right, so that's going to be 2,500 plus 400 is 2,900. All right, and the square root of 2,900. All right, we've got approximately 53.85 meters. All right, so that's our displacement right there. Okay, now your velocity is your displacement, right, divided by your time. So take the displacement, 53.85 meters, all right, and divide it by the time, 20 seconds, and what we get for our velocity, all right, we've got 53.85 meters, 53.85 meters divided by 20 seconds. Our velocity is 2.69 meters per second. All right, but we really should get our angle here. Now, the angle we actually want is this one. So that's this angle. All right. You need that angle for the displacement. You need that angle for the velocity. So let's get that angle right now. All right, just to finish this off. So we're going to calculate this angle, which is the same as this angle. This angle is the one that we really want because he's not going just east, he's going, right, south of east by this angle. So we're going to get this angle because that's the angle that we want. They are the same angle. All right, we're going to use tangent. Okay, tan theta is opposite over adjacent. All right, opposite this angle is 50 meters. Adjacent to this angle right here, all right, is 20 meters. Okay, So we've got 50 divided by 20, that's 2.5. All right, do that on your calculator, 50 divided by 20. All right, but I don't want the tangent of theta, I want theta, so I want to get rid of tangent. To get rid of tangent, do inverse tangent, you have to do it to both sides. All right, tan and inverse tan cancel. Theta is the inverse tangent of 2.5. All right, do that. All right, second tan of 2.5. And what you find is that the angle right here, all right, is 68.2 degrees. All right, so now we have our velocity over here, which was 2.69 meters per second. All right, that's the magnitude of the velocity. Let me just double check that one more time. It was 53.85 divided by 20 seconds. 53.85 divided by 20 seconds. Yeah, 2.69 meters per second. All right, so now to state the entire velocity, you need to state the magnitude and the direction. Okay? So, the velocity is 2.69 meters per second. All right, 68.2 degrees. Guys, not east, but right, south of east. 68.2 degrees south of east. All right, that's our magnitude and direction of our velocity. Now, if they only asked for the magnitude of the velocity, then you would not have to report the direction. If they just said calculate the magnitude of the velocity, there's your magnitude. Okay? So, the main thing that you want to remember about the difference between speed and velocity. Speed is a scalar. We don't care about direction. It's calculated by figuring out the distance covered and dividing it by the time. Velocity, on the other hand, is a vector. It's calculated by figuring out the displacement and dividing it by the time. The directions are important here. Right? Directions are not important here. When you report the speed, you're only reporting a magnitude. If you report the entire velocity, you're reporting the magnitude and the direction. In a case like this, the direction involves an angle. I will see you in the next section.